Absolute error. Right. Can I ask you what you think we mean by error?
When you do it wrong.
No.
A problem.
No. It's not anything to do with it's wrong.
Is it like when you like divide by 0, you can't do that? So it's like the things you can't do with absolute value.
It's not, no.
Is it like when you have like an irrational percentage thing or something, like you can't round it?
No. No. It's nothing.
How far like a number is from the absolute value?
Oh, it's if you get a negative.
Well, I
number
think you're
percentage.
a bit too much now. It's got to do with absolute values, but it's really understanding this word. What do we mean by an error? It's not actually nothing to do with doing anything wrong, because we're never going to analyse doing something wrong, right? So we need to really understand what this word error means. Yep.
The actual amount of error in a measurement.
Okay, so you've used the word in a sentence from the book.
What page is that?
But I'm not after what absolute error is, I'm after what an error is.
Oh, a mistake. Wait, where is that?
I've just said it's not a mistake.
In
It's when
Page 219 I'm looking at, guys, but it still doesn't really tell us.
the true value, measured value.
I just want to know what an error is before we move on to this absolute errors and percentage errors. An error is not a mistake.
It's a learning experience.
Is
Is
it
it like the chance of like stupid, but like in this table here, it has like two things, and like one of them you calculate more like in depth than the other one. So that's what error.
What do you mean by in depth?
Like one of them you calculate like I don't know where I saw it, but you calculate it like millimeters or something, and the other one would be in like centimeters. So
Okay.
the millimeters one is more like exact. So then the absolute error would be
What
like
what better word could we use? Let's start using that.
Precise.
That's what
Accurate.
accurate. Let's start using that
So
word
the
appropriately now.
I do not know
would
the
be
difference, I'll just say
the
whatever one.
difference between those two.
Okay.
I'll
So
just switch it.
what does you guys and most students out there will use the word accuracy incorrectly. Yeah. I'll say, well, why did you do it? Because we're more accurate. No. What is accuracy again?
Getting it right. Getting it right all the time.
Precise.
How close we can get to the target multiple.
Isn't that precise?
Degree.
Oh no, it's
Don't have
not.
the number of times.
Or like
No?
how close
Oh,
you can get to
Close
the
you
target.
get to.
Okay, how close you are to a target. Okay, what's our target? The exact answer, right? So yeah, you can compare it to firing an arrow at a target or darts and dartboard. Your target is whatever you decide your target is, yeah? And your accuracy is how close you are to that target. Now, what can change your accuracy in maths and numbers? Well,
Negative.
no,
Equipment
not
that you
negatives.
use.
So no, not negatives.
How-
But why would equipment reduce accuracy
If
or
your
increase accuracy?
ruler doesn't measure.
Okay, so we're actually then looking at rounding, aren't we? And the appropriate amount. So as soon as I round an answer, what do I do to its accuracy? Decrease it. Yeah. If I measure, okay. How does anyone have an interest in horses?
My sister does.
Do you know how horses are, guys? Do you know how horses are measured? You never heard of horses however many hands tall?
What?
That's how they measure a horse.
That's not accurate.
Really?
Though.
That's how my mom measures
Good.
like tables.
Because
and stuff.
hands are different.
inches.
Yeah. But that's why tradition, like, do you know where measurements came from in the olden days?
Wasn't it like whoever the king was? It was like his foot or something.
Exactly, yeah.
No, it
Yeah, no,
It really is. So, like, Queen Victoria decided she didn't want the yard measurement to be what it used to be. She wanted it to do with something with herself. So she changed it. So back in the day, but yeah, you've kind of got your foot length, your yard, an inch was about the length of that, and that's how people measured. They went along and they measured cloth using that bit of their thumb. And people's thumbs don't vary hugely, they do vary some, right? So if I went with a thumb length, I could be more consistent than if I went with an arm length, for instance, because arms could change. But we've got feet, and they do come from body measurements. And horses were measured in hands. You kind of how many hands tall it is. I think they still use it, but they're not very accurate, are they? Because what do you do when you get to the top and then suddenly your hand is not quite enough?
And a bit.
Yeah, you go, well, let's ignore the little bit. So this horse is 25 hands tall. It's not 25 hands point something. It's just 25 hands. Yeah. If I gave you a meter ruler, a meter stick, right? Back in the day, a meter stick. Have you seen the pictures of the actual meter? First time some French guy worked out what an actual meter was going to be. We watched that video, yeah. It's like, never seen that before in my life. No, never seen it.
I remember it now.
The original meter was just a metal rod. No markings on it, right? And how do you measure? So what do you measure meter? So you do 1 meter, 2 meters. What happens if it's not a whole meter?
It's just not
One
there.
centimeter.
Centimeter.
You don't have centimeters.
You just leave it.
You've got meters
And a half.
and a bit. It's not quite 5 meters, or it's a little bit over 6 meters, right? So what can we do? Well, we can increase our accuracy. And how do we increase our accuracy? We mark it. We mark it smaller and smaller. So then we have centimeters, and then we kind of go, well, actually, we need to be a bit more accurate. So we went from centimeters and we cut them down into millimeters. And every time we cut it down, we can be a little bit more accurate with our measurement. You notice how I'm never saying it's wrong. My measurement of 5 meters and a bit is not wrong. It's just not very accurate. And it kind of comes to a head when, I'm sure I've said this before, and it was on that show, that documentary we watched, when there was the space shuttle going to the moon. Remember something like that? And it was like the calculations they made for the angles at which the shuttle had to leave the Earth, if they were something like 1,000th of a degree out in their calculations, they would miss the moon by 1,000 kilometers or something ridiculous, because it's such a big distance that tiny fraction was enough to miss the moon completely by a long way. All right, so that accuracy needed to be to a greater degree, otherwise they were going to not get what they needed. Now, do we always need accuracy to 1/1,000,000th of a millimeter? No, we don't need it, right? However, what do you think it's called when we accept the and the little bit? Because we always have a and a little bit, really, don't we? When you're measuring to a nearest millimeter with your eyes, it's always going to be a and a little bit. We just don't care. That's the error, isn't it? The and a little bit is our error. So it's not an error in terms of doing something wrong, okay? It's the difference between the exact answer and what the answer I get with the given accuracy that I'm working on. Does that make sense? So that's what an error is. Now, then we've got to think about, where does this absolute error come in? All right? So let's have a look at the form. It's in the book. It says, the absolute error of a measurement is the actual amount of error in a measurement. So this symbol, absolute error, is equal to the true value minus the measured value. Now, I haven't put the absolute in yet Because why do we want an absolute value of that?
Because it's even if the true value is like less than the measured value, it's still like you're off by a positive number.
Yeah, I don't really care whether I'm above or below. All I want to know is how far away I am. Yeah, does that make sense? So if my measured value is slightly more than my true value, I would end up with a negative number. If it's slightly less, I would end up with a positive. Now, why does that matter? Well, if I've got lots of different errors in my calculations, some of them are above and some of them are below. And if I add up all that error, what am I going to end up with? Well, if some are above, some errors are above, some errors are below. If I add up all my errors, I could end up with
The right number.
0 error. That makes sense? Some are positive and some are negative. Add all those values together. All right? Why might I want to add all my errors together? That might be the next stage. If I add everything together, I would then
Subtract it from what you get.
and what would that be doing if I distributed that sum of error equally? Working out the what error?
Percentage.
If I add up all my numbers and divide by the number of numbers, what do I have?
Average.
The
Mean.
mean. So I could work out mean error, couldn't I? If I have lots of things going on, I could add up all my errors and divide by the number of errors, and I would get my mean error, yeah? So let's say I was doing something repeatedly, and I was getting errors, yeah? Some above, some below. But what happens if I add up positives and negatives? Potentially I could end up with 0. And that would suggest that I could have errors every time, but if I add them all up, if some are positive, some are negative, I get a 0 error, which means that when I do the mean, I get a mean of 0, which doesn't represent. So what we need to do is we need to think, I don't want positives and negatives, I just want positives, right? An error means an error, whether it's above it or below, yeah? That makes sense? So how now can we make sure that I just consider how far my value is away from the actual value? The absolute, isn't it? So we had a method of saying that the absolute value is how far away from 0. So in this case, 0 is not the number. 0 is how far away from the actual number. So what I'm actually looking for is when I do the absolute error, I'm saying how far away am I from what I want? Above or below, I don't care. Yeah? Make sense? Okay, so that's our absolute error. Then we can go straight to our relative error. Okay. So our relative error in a measurement is compared to the size of the thing being measured. Why would I want to know, take that into consideration? Yeah.
Because if you're measuring something bigger, then the error is going to be less significant. If it's like
Yeah. So what's a huge error in if I'm trying to work out the distance between stars in the galaxy? So if I tried to measure between two stars and I did my calculation and then I could actually go and physically measure it, let's say I was 400,000 kilometers out. Big error, small error.
That's big.
how far away are stars?
Stars
are like 3
Not on
light years
galactic
away.
level.
400,000 kilometers would be nothing in terms of galactic levels, right? That would, if I could measure between stars and get it within 400,000 kilometers, I'm doing really well. I'm happy with that. All right. But if I'm trying to measure the distance between Hamilton and St George's and I'm out by 17 kilometers,
So bad.
If I'm trying to measure the length of a table and I'm out by 2 meters,
Well, that's different.
now it's just getting stupid error. It's like if I try and measure this table and I get it 2 meters too long, I'm like, that's a big error, right? So the relative error means relative to what you're measuring. So let's have a look. So the relative error is the absolute error. So we've got that above. Okay, but divided by the true value. So it's like saying, well, I'm 2 centimeters out when I'm measuring something that's 3 meters. So 2 centimeters out of 3 meters. You could work it out, yeah? So I turn it into a fraction, basically. And then finally, this one, the relative error, we don't tend to stop at because then we go to our percentage error, which is absolute error divided by our true value. Okay? But written as a percentage. So how do I do it as a percentage? Multiply by 100. Yeah? So I have a decimal as a percentage. Why would I want to use it as a percentage? What's the reason for percents? Nice, useful tool, but you know what it is? Why is it useful? Why did someone, I mean, this is one of those things that you just take for granted now, but the first person to say, hang on, why don't we do this and call it percentage? They were like, yes, that's an awesome idea. Now we can compare everything. Why does it compare everything?
Because, like, if you put something in terms of percent, it's not just like a number. Like, you can see how much out of 100 it is. So they're all like.
So the important thing is
Right.
everything's then out of 100, right? So you break everything into 100 parts and figure out how many of them you have. So it's a real nice. So it's that relative error thing is again, isn't it? 400,000 kilometers out of 5 light years multiplied by 100 gives me 0.001%. Yeah, probably a lot less than that. But 2 meters out of 1.5 meters means I've got an error of 220%. Yeah, you can compare that really easily and decide who's better off. So that's why percentage is a lovely way of comparing different sizes of things. Yeah, all right. Who is doing better at school? So would someone do? Let's compare 2 students. One student got 80% in their test, and the other student got 30% in their test. Who's doing better at school? Really? Previously, that first person got 83%. The other person got 15%. Who's doing better at school? Well, I would argue that the second person has lower scores, but they're improving. The other one's getting worse. So it's about that who's doing better analysis, isn't it? Yeah? So you might, why is the higher score, but maybe they're coming from a point where they've already done all this before and the other student has never done it before. So they're progressing, the other one's good. So you've got to think, you know. So we could look at it in terms of percentage improvement is another way of doing it. All right? So that's why I kind of say to you on assessments, it's not about your score, it's about how you did compared to last time. If your scores get better, that's what matters. Right? If your score's not getting better, then, you know, we're not doing quite so well. Maybe you've stopped learning. Anyway, so we've got this percentage error, right? I think we've just got to be able to use it, right? But it's quite an important thing to understand error. So should we have a look at a question then? if you turn over the page to page 220, okay, let's just do question 1. So Elias estimated that 20 people would attend an evening lecture. In fact, 23 people attended. Find the percentage error in this estimate. So what do we do? So first of all, let's find our, you can do this all in one go in the future, but let's do our absolute error would be 20 subtract 23, but we're going to do absolute value, so that's 3. He was 3 people out. Whether that's above or below, I don't care. All right. His relative error was, well, he was 3 people out of 20. Okay. His percentage error then was 15%. Okay. Yes.
So if the relative error is absolute value over, absolute error over true value, then isn't the true value 23?
No.
20?
Oh, sorry. He estimated 20. Yeah, sorry.
No.
Yeah. So 3 over 23. That makes it harder to do as well.
My bad.
Yeah. Do you know why I made that mistake? It was a true mistake because I was listening. Why did I make that mistake? Exam tip. I didn't write down on my paper. I didn't take out the important things and write them down. I normally do. I didn't in this case. Now I can actually see on my page. Right, so you should take out the important stuff. Otherwise, there's no way of checking. But what's that then? 3 out of 23 as a percentage error is? Pardon? 13.04%. Okay. Okay, easy then, right?